Okay, show me what I'm sharing. Okay, you guys can see the screen, right?
Yeah, it is visible.
Yeah, I think I don't want to share the output, but you guys already looked at it. So that's fine. So you guys can see here now. What I'm going to do is let's you can see the um, two arrays here, right? So here are two arrays, and what will be the output? So can you tell me the result? Result is like union.
One, two,
Union, yeah,
three.
union array equal to, yeah, one union array is one. So basically, that's a good point. So the given two arrays are in sorted order, create intersection, union intersection also in a sorted order. That is the main condition here. And maybe what you can do is remove duplicates. This is another condition here. I don't know whether in real mathematics we remove duplicates or not, but here we are going to duplicate. Yeah, go ahead, Tarun. What will be the output? One.
Two,
Mm-hmm.
three, four, five, six,
Yeah,
eight, nine, 10, 20.
9, 10, and 20. Yeah. So, what will be the intersection?
I think three, five.
Mm-hmm.
That's it.
Yeah.
That's it, right?
Only three and five.
Yeah. So, this is what we need to print. So basically, so the algorithm need to print those two arrays. So it looks very simple algorithm. So what is our strategy to print these two arrays? Print, or you can also create those two arrays and then print. Printing is next one, but first we need to create those two arrays, right? So we do first of all, we don't know how many elements we have to add to the arrays. The maximum is, let's say these A and B are completely unique, right? A and B are completely unique. Then the maximum will be the number of elements. The union array will be what will happen. Let's say this has n and the next one has m, right? So the maximum it goes all the way to
N plus M.
n plus m elements. We know that is the maximum size. Okay, because if they all are distinct, you have to consider every element. And intersection, what is the maximum intersection?
Like max of MN, I think.
Max of mn. Do you know how can you do that? Max of the intersection is common elements.
Right, right.
So
So
if there is no
I
common
think
elements, it will be the array size will be
zero.
zero, because there is no need to put any elements. But we don't know, right? Until you scan the elements, we don't know. But what will be the maximum size? It can go maximum size will be, I think it could be the min
Like
of
one
n.
of the array will be okay.
It could be the min of nm, because let's say all the elements of B are in A. Then size it could be size of B, right? It could be less than that too. Like, see here, like we only took the numbers which are in common, and we removed the duplicates. We also need to remove the duplicates. We don't want to, let's say another three is in B or another three in A. We don't want to consider that three. So it could be either zero or at max, right? At max, whatever is the minimum, it may not be max. How it can be max, right? So, but anyway, we no need to super worry about this min or max. The only thing what I'm saying is let's take two arrays and you can initialize the size with n plus m. That's not a problem. You can take n plus m size for this array. You can take n plus m size for this array. Because when you create an array, an array, you need to have the size, right? So that's what I did. So even I look at this. So intersection union, I took a length one plus length two, which is okay for the time being. We don't need to worry about how much size we need to do. Our only worry is how to create these elements and how to create these in union and intersection elements. So what is the strategy? So you already created. You said one, two, three. Why you started with one? So just try to
Sorting.
find out our strategy. Yeah. Tarun, what you did while you telling this answer, what thought process you did? That's what we need to code actually.
Yes. I just started with the lowest number
Lowest number
as
of what?
we need to
Lowest number of, because these two are sorted. Okay. So lowest number between
arrays.
arrays. Okay, that's good. Okay. And then what you did? How two came into picture? You started with, because lowest number is one and you put one is in the union array, and you did not put one in intersection array. Why? Because
One is unique, like it's available in only single array.
single array. That's good. And okay, next one. Then how two came into picture? So one, after that one is three is here.
So
What you did next?
yes,
Yeah,
I compared other array rather than one. Is there any bigger number? So I just
mhm,
moved to two. Two is a bigger element, but first I just how it's I will compare from the array B. I will see three.
exactly. Okay.
So
Yeah, basically two pointer approach.
Yes. So basically, you compared three and with two, isn't it?
two.
Because
Yes.
in the A you are still at two because you haven't even considered two, right? And you compare two and
Yes.
three. You compare two and three, and finally you put the two here because that's the next number, right?
Lowest number.
Lowest number. Okay. Next, what you did next? Now you're going to compare three
Then
and three. Yeah. Go ahead.
I move to next index.
Mm-hmm.
It is tree, and I compared with the array B. So the both are common in the array.
Yes.
So I added to three to array, and I just move to next index.
Next index in which array? Next index, because which three you took it? Did you took the three from A? Did you take the three from
Three from
C?
B.
Okay, three from B. Okay,
Hmm.
okay. If you take from B, then now three and five you're comparing, isn't it?
Yes.
Then what you do? Three is the answer. So like three is the smallest one. Then what you do? We are not putting three here, right? Because three already there, isn't it?
Yes.
So you are skipping 3. You skipped the second 3, isn't it?
Yes.
Okay. Now let's assume 3. After 3, there is one more 3. Wait, what did it? So here is 3 and here is 4. Let's assume there is one more 3 here. Then what will happen? So now you consider this 3 and this 5, right?
Yes.
Then what will happen? You going to put the 3 here in the union array?
Uh,
You should not put it, right? It says remove duplicates,
yes.
isn't it?
Mm-hmm.
So now you found another 3. You already took these, you compared these 3, 3 and 3, and you put the one 3 here, and then you skipped the second 3. Now you got third 3. This is another 3 here.
Mm.
And you're comparing 3 and 5. Okay, 3 is smaller, and you're going to put 3 here, another 3 here, but you don't want to put it, right? How to skip it? Basically, is that 3 already in the array? But do you need to compare from all the way from the beginning? Not required, right? Because
Yes.
you just need to just look back. Hey, 3 is already there. Okay, if there is no 3, let's say these 3 and these 2 are not there. If these threes are not exist, this 3 doesn't exist. So then you consider this third 3, but you already considered 3. Then you skip putting that 3, isn't it?
Yes.
So you need to look back just one element before you putting the element. Similarly, see this next one also, 4. You put the 4, you put the 5, and then you got another 4. You don't need to put 4, because you just look back one element and see whether that element already there. If that element already there, you can skip this another 3 as well, isn't it? Okay, are you guys following so far?
Yeah. Yes.
So why are we doing all
So
this?
we need to like,
Yeah, go ahead. We need to.
I was saying, so we need to put a duplicate condition so that so
Hmm.
that duplicate number do not come.
Yeah.
Compare with the latest like element pushed in the array.
Mm-hmm. That is the thing. So
So
because
that
in order
duplicate
to,
can be
since we need to remove duplicates is another condition, we should not put duplicates before you putting the element into the in union or intersection. We have to compare what is the last element you put it in the array, because we know these elements are in sorted order. So you just need to look back one element is fine, right? Because you will not get
right,
one
right,
two in these numbers. There is a rule. You will never get 1 2 or any other number. You no need to start from scratch. You just either you will get another 3, either you will get a separate number like 4. So you just need to look back one number, isn't it?
right, right,
So that is the condition here. So see, I'm just running again. See, I ran again. I put another 3 here. I ran again. The output is same. There is no change in the output. So now let's revert back and let's discuss a little bit about the complexities. Before discussing, let's look at the input like this. Okay, input is something like this. It's not sorted. Let's say it is 5 here, it is 2 here, and in place of 5 you got 2. Okay, so in place of 9 you got 4, and here in place of 4 here it's 9. Okay, this is exact same numbers. See, you have 2, and okay, I missed the 3. Yeah, maybe you can put yeah, in place of 3, like, yeah. So we have 2 3, 4, 4, 5, 8, 9. It's the same numbers, but they are not in sorted order, right? So here is 20, here is 1. Now how you solve the problem? So basically, we it's not in sorted order, and we also need to remove the duplicates. And let's say you want to put the result in the sorted order. Okay, so there are multiple ways to do it. So what is the approach you do it to solve the problem? Because the problem is, let's say, first you take 5. Okay, you need to know whether you need to put 5 in the array or not in the result. Okay, so here what you do in the result. Okay, union array ua equal to, you want to know whether you want to put 5 or not. Okay, union array is easy because every element will be there, right? Of course there shouldn't be any duplicates. Okay, so now it is empty, you will put it intersection array. Here is the difficult part. You want to know whether you need to put 5 or not. What you do, because the arrays are not sorted, you take the 5, and what you do?
Like we take 5 from like the array A
Hmm.
and like compare it with every element of B.
Exactly.
And if we found a match, then we put it in like our resultant and then move to
Exactly.
next element and repeat this process.
Exactly. So you scan, you take the 5, and oh, 5 is, I found the 5 here. Okay, put it here. Now take the next number 2. Okay. 2, you simply put it in the, before you putting 2, what you need to do? There is a rule, do remove duplicates, right? You need to scan the entire array, because this is also not sorted. Make sure, let's say this array has already have 10 elements. You need to make sure before putting 2, you need to make sure 2 is not in the array already, right? So you need to scan this element, you need, because it is also not sorted. You need to scan
Right,
this element, and
right.
if you did not find 2, you can put 2, isn't it? Arun, are you following so far?
Yes.
Modit, so because I'm giving you what is the advantage of sorted behavior, because here the arrays are not sorted. It is so difficult, because it's not difficult, it's a different process you need to follow. Or another simple solution, you know what? Simply, what is another solution? Simply what you need to do,
Like
you can,
for intersection, there is one way like combine both the arrays and then sort it. Like
yeah, actually combine both arrays. You can simply, you can sort each array. That is also possible, right? Sort this array, sort this array, and then follow the same
right,
algorithm that you guys already discussed. That is another approach. See, this is not gas station kind of problem, because this is a kind of little bit freeness. You can have a freedom. You can have a freedom where you can solve the problem in a different ways, isn't it?
right.
Right? So now let's look at trade-off. Let's look at the different trade-offs between different algorithms. So first we discussed about this one, right? If the array is not sorted, you are taking an element 5 and you are searching the entire B. You and of course, for union you no need to find, you can put 5, but intersection you need to search entire B, and you found 5 here, that's why you put it here. Okay, now for 2, you put it in 2 because 2 is not doesn't exist in the array yet. You put it 2 here, and again, can we put 2 in the intersection? Can we put 2 here?
No,
No, because what you
No.
do, you are scanning the entire B and you did not find 2, so you did not put it there. Okay, now what we are doing? Next, 4. 4, you just put it 4 because 4 is doesn't exist in the array. And did you find 4 here? No. So this algorithm works. This will also give you final algorithm. Let's say the result says result we want is like unique element, basically remove dupes, and no need to sort. So you no need to sort this. It's like 5, 2, 4. The next element will be like 9. So you can simply you can create the algorithm like this. What we discussed is you're taking every element from one array and you're comparing with every element in the other array. And finally you are creating this intersection and union. Okay. So now let's talk about the complexity of this algorithm. This particular algorithm.
One doubt, sorry.
What is that?
Like I have one doubt.
Yeah, yeah, sure.
So like we have to make union and intersection like consecutively, like together, like both arrays,
That is a very good question. Can we do that or can't we do it?
or we need to like do it separately, like
Yeah.
running two different programs
Why you need? Is it really necessary? The ultimate output is I need two arrays. It's up to you. How can you perform? What is the optimal way to do it? Optimal way to do it is creating those arrays simultaneously
together,
together. Exactly.
right?
Because you're already scanning, like you're taking 5. Okay, you're putting 5 and keep quiet. Why do you need to keep quiet and going to the next element? Let's search that 5 in the second element, and if you find the 5, put the 5 in the intersection array immediately, so that you don't need to scan 5 two times, isn't it? Now you're taking 2 and just putting 2 and again scan the entire B. If you find 2, put it in the, so you can build these two arrays at the same time. That way you are looping the array A only how many times? Only
Once.
once, only one time. Tarun, are you following so far?
Yes.
Because we don't want to, let's say this elements is 1, 2, 3, 4, 5, 6. How about 1 lakh elements or 100k or million elements? If the A array has million elements, you don't want to loop the array A 2 million times. Just loop only 1 million time,
Mm.
right?
One.
So just think, always think about the bigger numbers, bigger elements, or bigger inputs. If the input is bigger, your algorithm will take more time. We don't want to do that. So just scan once and do the two things, like create the union array and also create the intersection array. So which is good point. Now you guys understood, right? So we will build the both arrays at the same time. Now what is the complexity of this algorithm? So A has n elements and B has m elements. We don't know which one is bigger, which one is smaller. There is no rule. A could be small and B could be big. So what is the algorithm complexity of this algorithm? Can anyone guess?
So suppose in array A, suppose we pick five, and then we have to like we will put in our union array and then compare with every element of B array.
Yes,
So like it's like n into m, like big
exact
of n into m
of order n into m.
of n.
Is that right, Tarun? Or any questions there?
Yes, it's right.
Simple, right? Let's say it has 5 elements. How many elements we have? 1, 2, 3, 4, 5, 6, 7 elements. You have 7 elements here. And how many elements here? 1, 2, 3, 4, 5, 6. So for every element of this one, you need to scan the 6 elements. So 7 times you need to scan 6 elements. So 7 times 6, 7 into 6, isn't it?
Yes.
That's the max. Of course, the problem here is another. There is a hidden thing here. It's not only 7 into 6. Probably you can take it, but there is one more thing here. You need to scan the union array as well. Before putting any element, let's say you want to put 9, since this is not sorted, right? 9 could be here, 9 could be in the middle, we don't know. So before putting 9, you need to scan these numbers as well, isn't it?
As it unsorted.
Yeah, because it's not sorted. So it could be order of n plus m plus some constant number. It could be constant, or we don't know, like this could be what is the maximum size. As I said, at the max it will be order of it will be n plus m, right? N plus m, because let's say you want to put all the numbers of this one and this one, right? Let's say you are putting the last element and you need to scan every element. So there is a constant time included here, but you no need to consider that it's a constant, because it's always based on the input size. So anyway, so order of, that's a navy solution. Here is a navy solution takes order of n into m time. Okay. Now I just said before there is one more solution to solve this problem, because you are unnecessarily taking one element and you are unnecessarily navigating all the numbers, because you're taking one number and you are navigating all numbers. It's not unnecessary, it's necessary, because you need to know whether the particular number is there or not. You need to know that there is no way, to in order to put it in the intersection array, you need to scan the elements, isn't it? So what we can do is, other solution is sort input elements. This is solution one. This is the solution one is solution one. Compare each element with each element of B. Basically, compare each element of A with each element of B. That's a one solution. You are not sorting anything. But now solution two is basically, as I said before, sort the input arrays. Input, right? You're sorting the input array. So step one is sort A, sort array A. Okay. Now you will get sorted A. Now sort array B. Okay. Now you will get sorted B. Okay. So let's say people say, like, there is a method called sort, or you will sort the array B. Then what is the algorithm? Now you guys sorted. Now it will be just like the same thing like this, right? if you sorted if you sort the same numbers, you will get this, isn't it? 2 3 4 4 5 8 9 and 1 3 5 6 10 20, right? Now you follow the same pattern what you just explained, Tarun and Modi, you guys explained right before. So what is the
Yes.
complexity of this algorithm? It's a two-pointer approach, isn't it? This is solution three because sorted. Basically, we'll come to the solution two. Okay, just a minute. Solution two is sort the input arrays and process. So the same process, we follow the same process, right? You take the so basically solution three is two-pointer approach. That's what Modi said. I like this word. It's a two-pointer approach because you're taking I and j and comparing these two elements and taking the small one and then comparing the next two small elements, isn't it?
Right, right.
So what is the complexity of this algorithm? Tarun, can you guess it? Just loops actually. It's very easy to for this algorithm. I know some algorithms it is very tough to find out. For this algorithm, we can definitely guess what is the complexity. How many times you looping elements of A and elements of B?
One time only.
Yeah. One time only means what is the total complexity?
Oh,
Order of?
of
Uh-huh. Here,
inflation.
exactly. Here is n elements, m elements. So you need to scan all the n elements, and n plus you need to solve. You need to scan all the m elements. M. That's it. Are you scanning two times? If it is two times, two into, let's say two into n plus m. Are you scanning five times? It's a five into. Just example I'm just giving, but it's a constant number. Even if you're scanning five times A and five times B, you can remove that five into. Do you know that? You can still say n plus m. Why? I want to give more explanation about this. You will, let's say you're scanning A five times and you're scanning B five times. So that means five into n plus m, isn't it? Right?
Mm.
So in that situation
Yes.
also, in that algorithm, let's say you wrote, you're just basic developer, you are kind of intermediate or advanced, but some basic developer who just passed out of college, or he just started, he wrote some algorithm where he's scanning five times A and five times B. That means 5 into n plus m. That is his complexity of the algorithm, complexity of his algorithm. But in that situation also, we never say 5 into n plus m. We will say that algorithm is as good as your algorithm, order of n plus m. Then you will be worried, oh man, why it is better. I'm just navigating one time n plus m. That guy, you know, did 5 into 5 times, but still it is order of n plus m. Do you know why? Anyone, Modit? Do you know why that is as good as the exact order of n plus m? Are you following?
Uh,
Of course, I am sidetracking a little bit.
yeah,
Why it is? Why that order of 5 into n plus m is equal to order of n plus m? Why?
because I think it is constant. So like,
Yes, it's a constant.
um, but like if you think about it, so it will still take more time. Like,
It's taking more time. It is taking more time. It's always not more time. The complexity is not telling you this many milliseconds. That we need to very carefully understand what is the complexity. Complexity is not equal to, you're not telling this will take this much time. It's if that is the case, then why you say O of something? You just say n plus m. Why you saying O of? What is that O of means? What is that O of? See, if I'm telling you, hey, tell me how many minutes it will run. Let's say each, how many seconds. Let's say each number takes 1 second. So n second plus m second. So you can simply say n plus m. So I'm not asking
right?
how many seconds or how many milliseconds. I'm asking complexity is always order of something, like, because we don't know exactly, right? If you have a very old phone, let's say your algorithm is running on a phone. Your algorithm is running on a phone which is very old. Let's say a phone, a 15 years ago phone. The same algorithm, the same for loop will take 10 seconds to run. But if you buy a very latest phone, it will run in a few milliseconds. It won't take 10 seconds. The same for loop,
Right.
because the
Yes.
processor is fast, the memory is fast, and it's so powerful. That chip is so powerful. It will run in a faster. So you never say it will take 10 seconds. So let's say this one take 6 seconds and this one take 4 seconds. You always say, hey, this will run in 10 seconds in every mission. You cannot say that, because that actual time will be depending on the system, their configuration, their chip memory. All those factors will tell you the actual time to run your algorithm. You cannot measure, you cannot by just looking at your for loops, you cannot measure the actual time, isn't it?
Right, right,
So the complexity is not about actual time. Complexity is all about how good is your algorithm compared to the other approaches. So this algorithm will go order of n plus m. That means irrespective of the mission, let's say order of n plus m means in one mission it takes 6 plus 4 10 seconds, 10 seconds. In another latest phone, order of n plus m, the same thing it will take maybe 2 plus six, in a very big phone. Let's say how many elements here, 1 2 3 4 5 6 7. Here is 1 2 3 4 5 6 elements. So that's why it's taking 6 seconds and 4 seconds. Let's say you have very great phone, it will take only 5 plus 3 milliseconds. It's again the same thing, right? It's again order of n plus m. So it's always that we are saying it depending on the phone. We are taking only some milliseconds for n elements, some milliseconds for m elements, and you are just summing it. But now this algorithm, this guy, another guy wrote so many loops, 5 loops or something. He solved the problem. That's why it is like 5 into n plus m. Okay, in a real fact, this algorithm takes more time. I know this algorithm takes more time compared to the logic you wrote, but the beauty of this algorithm is irrespective of the input. That is what I already told you before. Irrespective of the input, he is always taking this much.
right, right. So it is not dependent on any variable. Like
Yeah, so
it
basically,
is constant.
so of course it is increasing as part of the input, but it's a constant time. It's always for. It's not like, hey, for 10 elements, not 10. Here we have 3, 4, 5, 6, 7. Right here we have 7 elements, 7 elements, and we have 6 elements, 7 elements and 6 elements. So you're taking 5 into 7, 7 plus 6. Okay. Similarly, it's also like it's always like constant. You don't like what I'm saying is, so some you are taking, let's say your algorithm is taking, 5 5 milliseconds. Okay, his algorithm is taking 25 milliseconds, 25 msec. Now if your algorithm is taking 10, if algorithm will tell 10 milliseconds, okay, his algorithm is taking 50 milliseconds. Always like this ratio is same, right? You're taking like 5 times, isn't it? No, 5 into 10, yeah, 50 times, 50 milliseconds. So these two are equal because, like, he is not taking like, or if it is like, it will go, let's say if it goes to 500 milliseconds or 5,000 milliseconds, then it's a problem. It's not exponentially increasing, right? So you're taking 10 and he is taking 50, isn't it? So that's why we remove that constant time.
Right.
So basically, if it is exponentially increasing, then we'd say it's bad. So I'm just giving a little bit more details about the complexity wise. So, but anyway, coming back to our approach. So let's revert back and coming back to our approach. This approach is basically every element of A, and you are scanning only A ones and B ones. So it's definitely order of n plus m. Very good. So basically, we are using that sorting behavior, right? We know these elements are in sorted. Let's process in a sorted behavior. Now, coming back to solution two, let's say the elements are not sorted. So what you did is you sorted the arrays, and then you followed the same approach. Then what will be the ultimate complexity? So actually, so we need to calculate two things. First step, what you did. So this is like step number one, sort A and sort array B. Okay, and then process the solution C. Process as in solution 3. Then we need to
So
calculate
first,
complexity for this one, complexity for second step, and complexity for third step, isn't it? Yeah. So you do you guys know the best sorting algorithm, complexity of the best sorted algorithm?
yeah, n log n, quick sort, like
N
quick
log
sort
n.
and merge sort.
Yes. So actually, I have sorting algorithm class also. We like if you guys can follow all the way. I have around 10 types of sorts and around 10 or 15 types of sorts. I have sorting algorithms, and I can also like there's a very beautiful PDF also there. I can send that PDF actually somewhere. I will send it, but that will give you very beautiful explanation, very beautiful you know this thing as well, like figures. It's very very nice actually. So I will send that to you. You guys can see what are the different sorts we available. So I can see if I have it in my PC itself. So
Uh,
let's see.
just wanted to add here, like I heard of new sorting, like Suresh.
Oh,
It's like quick select sort.
quick select. Okay, quick select sort. Yeah, select sort. I know that there is a quick select sort. Huh? I don't know that. Yeah.
Yeah, so
There
it
is,
is specifically for one use case. So like,
hmm.
when we do quick sort, we are like dividing, like we find a pivot element and divide it in two parts, and then apply quick sort again on both.
Yeah,
So in quick select sort, we apply algorithm on single array only, like a half partition only.
I see. I see. Very good. Yeah.
So the complexity will be reduced to big of n.
Yeah. Yeah, I have that actually in maybe it is one of the sorts. I have it. I still need to figure that that PDF, but I will find out PDF or it's a word I think. But I will find out and I will send it. So that will explain really good sorting algorithms. So, but anyway, coming back to our discussion. So n log n order of n log n is the best sorting. You can't do before, like I don't think you can do better than this. Okay, so the order of n square is another one, order of 3 and 4 whatever it is, and the order of n log n is the best one. So order of n log n, let's right. So let's say this one has n elements and this one has m elements. So what is the final complexity here? Order of n log n plus order of m log
M
m,
log.
isn't it, plus
Yes.
order of,
M plus n.
because that's a solution 3, right, n plus m.
M plus N.
So this is the final complexity, because you need to consider the processing time for sorting, right? You're doing some process before doing actual final creating of the union and intersection. You're processing the entire array, and you're processing the entire array B, and then you're doing the actual processing. So that's why it is a complexity. uh is that someone joined? Divya, who is that? Hey, welcome to the class. Is that Divya? Hello? Yeah, I can explain the problem what we are discussing. So basically, we are discussing this problem. Oh, she left again. She or he.
See?
Do you know her or Taran?
No, I don't.
Maybe new person. That's fine. So if she joins, I can explain again. So you guys followed so far, right? This is the complexity of
Yes.
the total algorithm, the final algorithm. So now, so you guys understood this. This is the one we are going to discuss today, because You guys know this is a navy solution. Basically, you know, if the arrays are not sorted, you need to take the two for loops, one for loop for A and another for loop for B, and then you need to build this. But now, since they are sorted, right? So we need to follow different the approach which you guys said, like two pointer approach. Okay.
One doubt,
Yeah.
Suresh.
Yeah.
So like in intersection, like in solution third only, like I think. So when we do intersection of array, then also complexity will be big of n plus n.
That's right. But if you're doing combine, right?
Yeah,
See, that's fine. So let's say what you're saying is you want to build the union array once, right? That is order of n plus m. And you want to build intersection. That is also order of n plus m. Okay. Then the final complexity is order of 2 into m plus m, isn't it? 2 into m plus m, right? As I said, you can omit the constant numbers, isn't it?
yeah, but in case of intersection of the array, why complexity will be order of n plus n?
Uh, because you need to you want, let's say you want to find only intersection. So what you need to do, you need to take a number and you need to scan the entire. Oh, yeah. So why it is order of n plus m is you need to take a number and you need to compare with this one, right? So let's say 2. Okay. 2 is here.
Yeah,
No, because 1 is here and the next one is 3. Okay. Next, what you do,
okay,
you
okay,
take 3. You take 3 and again you need to compare. You already, like, let's say you are at the two pointer approach. Two pointer approach, you need to scan the elements of n and elements of m, right? So now see, you are comparing these two.
got it, got it.
So one is here, two is here, and now let's proceed with the next number. Do we have one since two is here? Okay, so you proceed to these two numbers, two and three. Two and three are not equal. You proceed to the next number. Three and three are equal. Okay. Now what you do? Since the intersection, you found three and three, then you increment both I and j at the same time, isn't it? It's like two pointer approach. You are
Yes.
using two pointer approach. Your two pointer approach, the
Right,
only thing you increment both at the same time is when you find the same element. In the I pointed to 3 and j pointed to 3, you found an intersection, both I plus plus and j plus plus, isn't it?
right, right.
Then 4 and 5, okay? 4 and 5 are not equal. Which one you increment? The intersection, which one you increment? Do you increment I or do you increment j?
I.
I, because there is a chance we don't want to lose track of 5, because look at that, 5 is here. We don't want to lose track of
Yes.
5 because this is a big number. We need to keep j and you need to increment I, and then 4. The second 4 and this 5, are they equal? No. Then let's increment I again. Then you find 5 and 5. See that? Then you put the 5
Got it. Yeah.
and then you increment 6. And now j is at 6 and I is at 8 because you increment both I and j at the same time. Now 6 and 8.
Like Suresh,
Yeah.
one doubt.
Yeah.
In the place of 5 in the array B, what if we have 4 number?
Very good.
So
Number
we
4.
need to,
If the 4 is there, right, these two fours will be compared, isn't it? The first 4 here and the first
yes,
4 here. Now what you do? Since both are equal, you need to increment I and you need to increment j, isn't it? Because you considered both the elements. Now what happens? 4 and 6, isn't
got
it?
it. So,
So let's
yes,
say
Yeah,
let's say
it's
here also
clear.
you found another 4. Now again 4 and 4. You found another 4, another 4. Then what you do? You should not put another 4 here. Before putting 4, you need to compare what
Hmm.
is the element I just put it there.
Hmm. If we sorted array means we can compare the previous element. Then
Exactly.
if it not sorted means
You have to
we
scan.
should perform after sorting only, right?
Yeah, perform auto sorting only, or you need to scan the entire array. That's the problem, right? Like here is before you putting any
Yes.
element, you need to scan all the way from the beginning. Hey, can I put 4 here? Can I put 9 here? Before putting 9, you need to see whether you have a 9 already, which is a very tedious process. We don't want to do that, right?
Yes.
So this is the main advantage of here. The sorting gives you better advantage before you putting the elements and also to process the elements. It's like double advantage. You are processing very carefully, and you are also putting into the result very carefully. You know whether 4 is already there, don't put it. Don't put the 4, but you need to increment both I and j, isn't it? Because these 4 and 4 are already
Yes.
considered. Then 5 and 10. That's the logic here. So that's why it is you are comparing entire n elements, and you also basically scanning all entire n elements, and you are scanning entire m elements. So that's why it is order of n plus m. It doesn't matter where for union or intersection, the same thing. Without scanning entire elements, you can't process. If you are scanning entire elements, that means n plus m. Since you are only scanning one time, right, with 2 pointer approach, you are not scanning the multiple times, you are only scanning one time. That's why it is order of n plus m. Is it clear? Actually, I did
Yeah,
not use the whiteboard, so if you want me to use whiteboard, I'm just explaining here only. But is it clear?
it's clear now. Yeah, yeah, it's clear. I was like a little confused for intersection, but it's clear now. Yeah.
Yeah. So actually, while doing, how can we do both at the same time? Like here is the problem. Like for union, you need to scan this entire two arrays, and again intersection you need to scan another time. But by by just scanning one time, you can create both the arrays at the same time, isn't it? So let's revert back the input. Basically, so here is 5, is 6, and here is 5, right? So now, so how to do in a single loop? Basically, we don't want to do um, intersection union one time and then intersection another time. So we want to do in everything in a single single loop. So now what we do here? So let's say I, right? So I equal to 0 and j equal to, okay, 0. Okay. So actually, we can use you can use whiteboard actually. So maybe this bit makes sense. Okay. Okay, it's like 2, 3, 4, 4, 5, 8, 9. Right? Let me write it down. 2, 3, 4, 4. 2, 3, 4, 4, 5, 8, 9. 5, 8, 9. Okay. Now 1, 3, 5, 6, 10, 20. 1, 3, 5, 6, 10, 20. Okay. Now let me do the indexes: 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5. Okay. Can you guys see the entire screen or only little bit of it? I think you're missing something there. Okay, wait.
No,
Can you
no.
can you
Everything
see
is
it? Can you see the top row as well, the actual
Yeah,
numbers?
yes, yes.
yeah, yeah.
Isn't 2, 3, 4, 4? Can you see the 2, 3, 4, 4?
Yes, yes. Full
Yes.
screen
Okay, okay.
is visible.
Yeah, cool, cool. Because then, so for some reason I'm not able to see in my other tab, so that's fine. So now what we do is, so let's do in a combined fashion. Our intention is to create the union array. Okay. Let's put here itself union array UA and intersection array. Okay, combine. So now let's try to write the logic. This is very interesting. So I want to put I want to put J. Okay, there are two pointers we'll take. Both will be considered 0 0. Okay, now what we need to put in the union array. Union array is simple. You need to put the take two elements. Take these two elements, this element and this element, I equal to 0, j equal to 0. What we need to put in the union array? We need to put the which one?
J.
Jth
We
element.
should compare first.
Exactly. We need to put
Mm.
the compare and take the which element? Small element or big element?
Lowest.
Lowest element. Exactly. Lowest element. Okay. So how to find the lowest element? Right? So simple. So
Less than operator.
what is that?
We will like compare both less than operator. Yeah.
Yes. So whichever is the small element. So basically, union array element, something like union array element. Okay, I think I used a different. Let me use the same terminology so that you will easy to understand before going. It says yeah, URLR. Okay, union result and union intersection. Okay, basically I used two variables, union result and intersection result. Okay, this is union result UR. Okay, and intersection IR. Intersection, we need to find which element to put here and which element to put here, right? So now UR is basically smallest of these two elements. If A of I is less than A of J, right? Then you want to take A of I. That's the UR, isn't it?
Right.
If A of J is less than A of I, then what will be the UR? UR will be A of J, whichever is smaller,
Yes.
isn't it? So now there is third condition. A of I equal to A of J. Then what will be the UR, union result?
So we will put any of both
Any
and
of
also
them.
put in intersection area.
Exactly. So
Yeah.
in these two conditions, IR is the IR don't change. IR, the intersection result don't change because both are different elements. But in the case of both are equal, then only you update the IR, the intersection result. Okay. So finally,
Yes.
after taking these all three conditions, finally you have these two numbers, UR and IR. If this is true, this will be the UR union result. If this is true, A of J is the UR union result. If both are equal, then both will be the A of I or A of J. It doesn't matter. You can take any of the, because both are equal numbers. You take these two. Okay. Now, now before you putting here, right? You can easily put it here, but the problem is here. You found out these two numbers, UR and IR. Before you putting what you need to do, there is one more thing. Remove duplicates. How do you do that? We just, let's say, so in order to put here, right, in order to put in UR array and IR array, I think I used variable K and L. Yeah, I think is it K and L. Yeah, K and L. So basically, I use two more variables, K and L. K equal to 0, L equal to 0. Basically, this will tell you uh, at which location I want to put these elements. Because now because at the beginning of the algorithm, you want to put at the 0th location, isn't it? You want to put the 0th location in the union array and intersection array. That's why K equal to 0, L equal to 0. I use K for union array, L for intersection array. So just Very carefully understand here. So these are the two integers I and j for iterating the array A and array B, and and k and l is to fill the elements in the union array and intersection array. Okay. So now after these three conditions, you know what is union result, you know what is intersection result. Now you want to put it at the kth location and lth location, isn't it? Right now it is 0. It could be like after 3 or 4 attempts, it could be like k equal to 5 or l equal to 3 or something. You want to put it at that location, something you already put some numbers here, and now you want to put it this kth location, and you want to put it lth location, these two numbers, the ur and lr, isn't it? But we want to remove the duplicates. What you do with that, to before you putting, you don't want to put the duplicate number, right? So how to avoid the
Yes.
duplicate number? How to avoid the putting duplicate number? You just need to compare. I want answer.
The previous.
Exactly.
So
Previous
like
number. What is the previous? Just the number you just inserted. Because all these are sorted order. You don't need to scan from the beginning. You just need to scan the previous number. Let's say you want to put here, but before you putting here, you just need to see whether this union result already here. Then ignore. Don't put it. If the intersection result is already here, don't put it. Don't increment k, don't increment l, isn't it? You want to fill these two locations, you have to increment k and l
yeah,
only if you are filling those numbers, isn't it?
Mm.
is like, but for the zeroth index, like
Yeah,
we will not compare.
exactly. That's beautiful. Very, very good answer. For the first time you are creating, for the first time you are filling, there is no a of -1. Index starts with 0. That's very beautiful, because that's the bug when you're writing algorithm. Unless you compare, unless you check whether if k is 0, l is 0, if you are previously comparing like k minus, basically what you are saying is, if u a union array of k minus 1, that's how it is, right? What is the previous? If it is k, this is k minus 1. If it is l, l minus 1, right? If u union array of k minus 1 equal to ur, this union result, don't put it. Or if they not equal to equal, then only put it. Basically you can write like that. If these two are not equal, if the element which is here is not equal to this element, then only put the element here, isn't it? But this condition has a bug here. If you simply write k minus 1, that will end up, your algorithm will crash, because if k is 0, there is no ua of -1. The index -1 won't exist, right? So
Right,
you will
right.
do this comparison, only if, what is that under condition, if k is
If not equal
Not
to
equal.
zero.
not equal to 0, isn't it? If k equal to 0, you can
Yeah.
blindly take this number and put it there. If the l equal to 0, you can blindly put the element. You no need to compare anything, because this is the first time you are putting, right? Isn't it?
Yes.
If k and l are 0, you no need to compare any comparisons. You can blindly put these numbers and increment k, increment l. But in case of, if k not equal to 0 or l not equal to 0, you need to take one more extra step of comparing the previous element. You need to take k minus 1 and l minus 1 and compare. If they are not equal to this number, if they are not equal to the result what you calculated, then only put the numbers, and then only increment the indexes. So very careful thing. This is one part. Create, like finding what is the union result, intersection result is one part, and putting the elements into the array is another part. Okay, there is a third
Yes.
part actually.
Yes.
Are you guys clearly following so far? So now increment I, like finally you put the numbers here. So finally what will happen? So you I for the I equal to 0, j equal to 0, what is the UR and what is the IR? UR is union result is 1, isn't it? Because small number,
Hmm.
right? 1 is small number and B and J will be incremented, right? And IR is what is the value you put for IR? IR is it's not intersection. There is no result for that. There is no result, isn't it? But how do you need to,
So you think,
you don't want to put IR here because there is no comparison, right? But what you're going to put there,
hmm.
you don't want to put 0 or anything, because if you put 0, that is also a valid number, right? It could be like in the input, if you have zeros, you need to put 0 in the, let's say 0 in A and 0 in B. You need to put 0 in the IR, isn't it? Let's say there are zeros already there in the input. 0 is also a valid number. So you don't want to initialize IR and UR with zeros. You want to initialize with something
Yes.
like integer dot min, integer dot min, something like that. So IR is still integer dot min value.
Integer dot.
Minimum min.
Oh,
Integer dot min. There are separate methods. Integer dot min, integer dot max. That will give you the minimum number and maximum number. So basically, you are initializing UR and IR with integer dot min. So so after doing this process, if the values are still like integer dot min or integer dot min, then you don't put it in the final array. But here the UR is not integer dot min. You are already updated with 1 because 1 is smaller than 2, isn't it? You guys following?
yes.
But
Yes.
IR is integer dot min because IR you did not change, right? Because there is no intersection between 1 and 2. 1 and 2 are distinct numbers, so there is no intersection result. So now, before you doing all this calculation, you need to compare, is the value is integer dot min. If it is not equal to this, do this whole process. So in this situation, what will happen? The union array will be 1 will be added, but nothing will be added to the intersection array because it is integer dot min, isn't it? Okay. Now what is the value
Yeah.
of I? After this loop, value of I will be,
1.
are you sure? I runs for A and J runs for B. You took the one.
0.
Yeah, you don't increment I because we don't know whether,
Increment j. Hmm.
yeah, only increment J. So based on the condition, if you are taking A of I less than or equal to A of J, you increment I. But if A of J is less than A of I, you increment only the J. If both are equal, then you increment both I and J. Isn't it? You guys followed? Now, again, I equal to 0, j equal to 1, and you reset the UR and IR because you need to calculate again what is the union result and what is the intersection result. Basically, you are comparing these two elements in the array. On the left side, I am just creating arrows. So you incremented j. Now you need to compare 2 and 3, isn't it?
Yes.
Modit, are you following?
Yes, Suresh.
So yeah, I'm just giving you step-by-step process of the entire algorithm. You know, it's easy. We are just thinking, oh, just 2 point approach, 2 point. I know it's a 2 point approach, but when you're writing it, that's where the crux of this problem here, right? Okay, 2 point approach, and how many variables we need, and how you going to write the loops. What are the conditions? These are the different conditions you have to think about. So you take these two arrays and now you are an IR. So now you reset them to integer dot min. Now you do the same calculation. if a of I less than a of j. Is it true? Which one? Which condition will satisfy now? First, second, or third? Or a of
We are on A of 1 and A of.
0 and a of 1. You are comparing 2 and 3 because you already took 1, right? 1 in the result.
Right,
So
right.
1 is already in the result. Now 1 is done. Now you are
So,
comparing 2 and 3.
so we will pick
2.
2,
A of
That means the first
A
condition
of
is
2, and I.
a of I is less than a of j. So you will pick the 2 and you to put the 2 in the final UR, but IR is again integer dot min, isn't it? UR is 2 and IR is again integer dot min. Okay. Now what you do, since you took the 2, now you increment I, isn't it? Now I is 1
I.
and j is 1. Now you comparing these two, 3 and 3. Which condition will satisfy? 1, 2, or 3? Which condition?
Third,
Third
third
condition.
3.
condition.
Third.
Exactly. This is the beauty. This is the actual thing where you update both UR and IR. Because when both are initialized to 1, you need to initialize UR and IR also to integer dot min. But now UR becomes 3 and IR also becomes, this is UR and IR. IR also becomes 3, right? Because IR is basically intersection result. Union is 3, intersection is 3, isn't it? Now you put the 3 in here and you also put the 3 here because there is no 0, is L is still 0. You guys so far following so far? Of course, I forgot to put the L here. This is the table where you can put the L as well. Let's say K and L. Okay, so K and L. K is already completed 0. Sorry, this is 0, this is 1, and now K is actually 2 and L is 0 because you already put 1 and 2. K is now at the 2. Now you put the 3 at this location. But before putting 3, you compare, do we have 3 here? No, we don't have 3 in the table. We have 2 actually. Put the 3 and increment K to 3, and then L equals 0. L equals 0, just blindly put 3 into this table. So you put the 3 here and then L incremented to 1. Now do the same process here. But here both are equal. In this situation, if the I and j are equal, we have to increment both, isn't it?
Right.
So now 2 and 2, 4 and 5 will be compared, and 4, the intersection union result is 4. Intersection result is integer dot min. You initialize again because 4 and 5 there is no intersection, isn't it? So 4 will be added here and k will become 4, and then you come back here. So now since you only intersect, so now it's 3 and 2, 3 and 2. Yeah, now you compare these 4 and 5, right? Again, the intersection union result is 4 and the intersection result is integer dot min. But here before you putting 4, you compare with k minus 1, right? So we already have a 4. Don't put 4. Don't put 4. Don't increment k. Don't increment L. Don't do anything. Just come back here and then do the next process and so on. Are you guys clear? It's
Yeah.
like very complicated. Looks like complicated, but it's not complicated. It's very very specific conditions that you need to write. So there is one more thing we are missing here. So until how long you go, because here I and j, the input could be like, the problem here is they are not equal. The array is really big and b is very small. When you are going with a two pointer approach, there is a very important thing you need to remember. When we are going with two pointer approach, what is the stopping condition, right? So the stopping condition is when you stop when you
When
when you
are.
ran out of numbers in one of the arrays. Go ahead, Modit. You're saying something?
I was saying the same thing, yeah. So till one of the arrays is like empty. I
Empty.
mean, like one of
Yeah.
the index,
Exactly.
one of the index reaches the exact length of the array.
Yeah, if the one of the index reaches the end of the array, then you can't do any comparisons anymore, and none of these, this will work. If you are going out of bounds, right? You don't need to do any of these calculations. You don't need to do, you don't need to find IR. But only thing you need to do is you need to update the UR. There is no intersection. I know. There you say, let's say B is done, and we still have a couple of elements left in A. Those elements may go to which array? Union array, intersection array.
U-
Huh?
Union.
Union.
Union. Yes, they may go to union. May. Why I say may? I did not say like they will go to. They may.
Because they can contain duplicates.
Exactly, they may be duplicates. Let's say you put 9 and you have another 9, 9, 9, 9, 9, and you have another 100 nines. You don't put 9 again. They may go to, let's say you have 10, 20, 30, 40 or something. Then they may come to the union array. So here we cannot say that A is bigger. We cannot say B is bigger. We don't know whether I ran out of numbers, J ran out. I reached the end of A, or J may reach end of B. So now, after doing all this, you need to see after the loop. Hey, is I is still less than N? Is J still less than M? If it is that, then you no need to do this conditions or this calculations, but you need to do these calculations, these kind of thing before you putting in the UR in the union array. You need to compare. If you don't have a number, if you don't have that the um, if you don't have the number, you just put the numbers, keep on putting the numbers and keep on incrementing the k, right? From A array or B array, whichever has elements left. Okay.
Right, yeah.
See, like when you're writing algorithm, you like it's not easy. I know. That's I always recommend. I don't know why these kind of questions will come up in interviews. It's very difficult to write entries. I don't ask this question. I will, even if I ask this question, if the people can answer these different approaches, I don't ask them to code entire algorithm. If they discussed about all these complexities, hey, we can do this way, we can do this way, we can do this way, and this is the trade-off. That's enough. Actually, that thought process is enough. Even if you write one for loop, even if you write this for loop for this particular conditions, if you are incrementing I in this situation, if you are incrementing j in this situation, if you are incrementing I and j in this situation, I will be super happy. I don't care whether you write all these if conditions or all. If I am the real interviewer, I know the difficulty, I know the pain of writing these many conditions and loops. If you are at least 50% succeeded in discussions and writing at least 30% of the code, I don't need entire 100%. I will be super happy with the candidate. You will ask Modit, I know what you're going to ask. How can I write this much logic in the interview? Right? You don't need to. As long as you guys are following,
That's great.
as if an interviewer is giving the inputs, if I'm the interviewer, I will say, hey, how many arrays you take? You say IR and UR, like I will take two arrays. And how many variables you take? You explain, okay, I will take I and J for A and B. I will take UR union result and intersection result in each condition. Oh, you are good. It's following. Then kind of how you calculate, man, how you calculate UR and IR. I will ask the question. You will say, hey, I will add these three conditions. In this condition, this is the UR. In this condition, this is the UR, and this is condition. And what when you change the IR will change only in the third condition. If you are keep answering those questions, that's enough. You're aligned with the thoughts. Both are having the same thought process, isn't it? That's enough. If you are my colleague, if I'm saying something, if you are catching and if you are giving the inputs, that's enough. The That's the main part of this whole interview. The interview process is not for writing. It's not a normal exam where you solve the mathematical problem and prove it. It is a conversation. It is a conversation between the interviewer and the candidate. Always try to, while you're writing the code, always, express your thoughts. Don't write just silently. Very few people will say, hey, go and write the code silently. But I'm not that kind of person. I will always say, hey, when you're writing the code, keep explaining, keep expressing your thought process. I want to know what you are thinking. I want to know why you are writing those logics. I don't want to wait for 20 minutes and then talk about the interview, talk about the algorithm. There is no point of doing it, isn't it? So every interview.
Yeah, but sometimes it get difficult to like do both things,
Yeah,
like
so not
explain
like
and write.
exactly what I'm saying is not every second you need to talk. You just take these two variables and write all these if conditions and then stop there. Stop there and explain. Hey, I'm taking these while are you taking while loops or for loops? Which loop is better for these conditions? Two pointer approach is always go with
While loop.
while loop. Exactly. This is another rule you guys need to remember. Two pointer approach means both need to start at the same time. That's why it's always two pointers. Like we don't know which pointer will go ran out of the element. That's why it's a while loop is better. Because it's not for loop, right? If you say for loop, both are not equal. If the size is equal, if the input says size are equal, then you can take for loop I and j at the same time. But there is a condition where size may be different, right? That's why while loop.
Right.
So I thought you guys understood the full algorithm. Any questions, or should I reveal the algorithm now? It's exactly the
Yes, Suresh.
what we just discussed. Okay, I'm going to reveal here. Tarun, are you ready?
Yes.
So, as I just said, these are the first we are calculating the length, and you initialize union intersection these two arrays, and I take these numbers I, J, K, L. I, J for A and B, length 1 and length 2, and K, L for the actual things. See this? For while loop, I less than length 1 and J less than length 1. We need to process this while loop only if both are within the bounds, right? If both are I is still valid, J is still valid, then as I said before, every time you need to initialize with minimum values, because you need to calculate what is the union result and you need to calculate what is the intersection result. Okay, now look at it. So I will use restroom and come back in 2 minutes. So now look at the if conditions here. So let me know if you guys have any questions in these if conditions and I will explain. Okay, be back in a minute.
Okay.
Yeah.
Like Modit bro, like min int dot min value is a default function. Is it for every language or do you know anything
Yeah,
about it?
so I can say for Java, so there is like integer dot minimum value and integer dot max value, like with underscore. It is for Java is for Java it is defined like inbuilt values.
Okay.
But I think for Suresh uses C sharp, so yeah, it is for C sharp as well. We need to check for C plus plus. Like, you code in which language, Tarun? By the way.
JavaScript, Java. Like, I am not good at Java.
Okay, okay. In JS. Okay, so you need to check for JS. Yeah.
Mm.
Tarun, can you tell me one thing? Why we take this value like UR integer dot min value?
I do don't know. Like I think we are assigning minimum value.
Right, right,
If we assign zero value, it is also rigid, right?
right, right. So, like if we are looking for minimum value, so we must, I think we must like assign max value in it.
Yes,
What is that?
min and max.
Hey Suresh, so I was saying that in line number 60, so we are like assigning integer dot min value.
Yes,
Why not integer dot max value?
that's a very good question. Integer dot, yeah, you can put integer dot max value also. It doesn't matter. It's only matters is you want to put, you want to consider that number if it is not equal to that number, right? So basically, if you successfully
Right,
found UR and IR, I think that's very good valid question. So you can put integer dot max value as well. It doesn't matter, it just need to have something which is not, because you are not comparing. Look at this, anywhere you are not comparing with, you are with anything, you are only using here.
right, right,
We are assigning in line number 63, you are assigning 67, and 71 also you are assigning. We are doing only, here is the comparison we are doing, we are not doing any you are less than f I, f b or anything. We want to make sure.
right, right.
Yeah, that's also, you can put max value as well. We can try it out. We can put, you can, let's try. Let's try putting the result, integer dot max value with max
So
value.
like I do this way. So when we have to find something minimum, so I initialize max value in it, integer dot max value, and when we have to find something maximum, I put minimum value in it. I put reverse.
Yeah, yeah, that's right. But here the intention is not comparison. The intention is, are we updated the value or not? Because you don't want to put into the intersection, right? If it is not updated. Similarly, if you don't want to put in the union, if it is not updated. So updated in the sense, if it is still having the same value, right? So you don't want to
Right, right,
put in the result. So because the intersection is
correct,
problem. For union, you will definitely update. Look at this. Union, you are updating every time. If it is A of I is smaller, you update, you put the A of I. If B of I is smaller, B of J is smaller, you put the B of J, and if both are equal, you put the A of I. But here, IR, look at the intersection result. Intersection result will be updated only in this condition if both are equal, right?
correct.
So, so you need to understand whether should I update or not. It's all depends on this value. If it is not equal to min, actually there is a problem here. If I change to min, yeah, I also need to change to min here. Otherwise it won't. I also need to change to max. If I change to min, right, max value, I need to put max value here too, because for the conditions purpose, right? If it is not equal to max, then only update.
Yeah.
So uh let's run, we can run. Looks like there are some errors. I don't know what is the errors. No, it's not. Debug console, huh? Oh, expected. Oh, okay, 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 okay. Oh, because we have this comments. That's a problem. And we also have inputs. So okay, this is not unsorted. Okay, this is unsorted thing. Okay, this is sorted. I'm just trying with max value.
Yeah.
Just running the code. Okay, it will work. So you guys understood this until these conditions, right? So you are, see, look at this. I we are incrementing only in this case. In this case, we are incrementing j. And in this case, if both are equal, we are incrementing both I and j. Okay. And what the heck, again there are some issues there. Where is that? No, we got it. Intersection, what? Oh, this is, we got the integer dot integer dot max value in the intersection. Why? Oh, because I put here. See, I need to update everything, not only here. I need to put here, here,
Right.
here. I think I forgot to update in a couple of places. So now it will work. I think now it will work without any issues. So if you update one place, you need to update everywhere. So now so then you guys following this algorithm here, right? The if conditions here. So this is the first process of finding UR and IR, right? And the next process is, this is what we discussed about. If k not equal to 0, compare the previous element, isn't it? If k equal
Yes.
else we just put simply put the value here, right? And you are incrementing k plus plus. K plus plus means k equal to k plus 1 basically. So, and you are putting the UR value, the union result into the union array. If it is not equal to the previous element, and if not equal to max value. If it is max value, that means you did not even update this. You don't need to put anything. Similarly here, right? If it is if else case means k, if k equal to 0, you can blindly put it. You can put the k in the union of k and you are incrementing k plus plus. Basically, this will put at the kth location and immediately after that k will be incremented. This is how in C sharp. I don't know whether in Java or other languages. Basically, you don't need to write another condition like separately. It's simply like union of k equal to UR and then it will increment the k value. Okay. Similarly, L for L not equal to 0, then you compare L minus 1. This is the checking. Otherwise, this will crash. If you don't have this if condition, the 0 minus 1 becomes minus 1. So that will crash. So here is the output. Come on, it's still running. Huh? Okay. See, we got the result. So even with max value also, we will get the same result. It doesn't matter whether it's min value or max value. So we are only, this is only used for the comparison. Okay. So if L equal not equal to 0, you are comparing. Is previous number not equal to the IR? If the previous value is equal to the same intersection result, it won't execute this line and L will stay there. Okay. Otherwise it will update the intersection. Now here is the two other while loops. This is also another thing you need to remember. Like when you do the two pointer approach, there is always a chance there are few elements left in the first array or there are few elements left in the second array, because this condition, look at this condition, it's an and condition. If both are within the bounds, execute these conditions, right? You are comparing only if you are within the bounds of the both arrays. If one of the arrays out of bound, like basically if you processed one of the arrays, you don't need to do any of this, but you need to consider those elements, right? Isn't it?
Yes.
So now I'm putting this here. Actually there is a bug, right? I did not even looking at the previous element. I think this may create problems, isn't it?
Yeah.
Yeah. See, it's like there is a bug here. See, I just found the bug because I found the bug only because we discussed it. Only because we discussed. We did not, like, before you putting the elements, we need to compare the same comparison has to be there, right? But why it's giving the correct result? Because there is no duplicates there in the given array. So let me tell you the bug here. So let's put something like this. Here is input array, right? Let's put 9 and another 9, or 9, another 9 and 10 and not 10 basically. Yeah, You can put 10, or let's say 25 and 25. See, you will get all the numbers. You will get duplicate numbers now. See, I found the bug here because I am blindly putting, take the elements from A and put it into the union blindly. I am not even comparing the previous number. See, you found the bug here, right?
Right.
Tarun, did you follow? What is the bug here?
Yes.
So let's fix that. First, let's see the bug. Let's see the wrong result. So then we'll fix it. So here is last one is just printing the result. I'm just looping the elements. Again, I'm taking another I variable from 0 to k minus 1 and printing the union. And I'm taking I equal to 0 to L minus 1 and printing the elements from intersection. This is just a printing part, output result part. Okay. Oh man, it's taking ever. Come on. So, okay, now we are getting the result. Yeah, so see that 20, 25, 25. So 9 is not duplicated. 9 is not duplicated, but 25 has got duplicated. Why 9 not duplicated? Because 9 you process before you process 10 and 20, right? So you put 9 there and you compare this 9 and this 10, and you also compare, all the both the nines will be calculated and processed within the for loop. Within the for loop, you have these conditions, right? You guys followed so far?
Yes.
But for these 25, 25, we are blindly putting into the array. That is the problem. So now to fix the problem, what we need to do? So before you putting the value, you just simply put that if condition, right? If
Mm.
if union of A not equal to A of I, right? So I is still there. You haven't even like I all the way is less than length minus 1, but in this situation j ran out of numbers. So now you are processing the values from the a. So not equal to a of I, then only do this. Else case, I can put yeah, I can put this so that it can easy to understand. So else case, what we need to do, simply I plus plus, right? Let's take the next number from a, isn't it? We need to do the same thing for here as well. Union, you don't need to do anything for intersection. You guys know it, right? K not equal
Yes, right.
K not equal to B of J, then only do this. Intersection, no need to update because these are all extra numbers. Else J plus plus, J plus plus. Okay. Now let's see. Now we should not see the duplicate 25. We are keep incrementing J. That's it. Simply. And without debugging. Even it is taking time. Very good, man. See, I am finding bugs in my code when I am explaining to you guys. Like I explained this algorithm last year, but I did not find this bug. It's all depends on the conversation. Unless you talk each and every line, you don't find bugs in your code. But let's say if you are the candidate and you are explaining this and you found bug in your code, I will be so happy because you are not only just writing the code, you are explaining the code, and also you are finding the bugs in your own code and you are fixing it. that's
Ex-
what that's what that's
Yes.
what we want a developer need to do, right? A developer, what we need from developer needs able to think, Developer should be able to come up with an approach. Developer should be able to come up with some kind of algorithm. It's not perfect in the world, and developer need to able to explain his algorithm, and developer need to find bugs or problems in the algorithm, and developer need to able to fix the things in their algorithm. That's it. These are the six attributes I see. As long as you're able to find and keep fixing the bugs, I'm fine. Like if I give you the project, I will get the confidence either by today or tomorrow. If I give you some task, right, I have full confidence on you that you will be able to fix the problem at some point. Okay, look at it, it still did not fix the problem. Why? See, this is interesting. Why? Oh shit. See, you guys did not tell me. It should be k minus 1, right? We need to compare previous,
Right.
isn't it?
Correct.
Yes.
Correct.
Are you guys following or almost sleeping? Maybe it's like,
No.
like 11 o'clock.
Both.
Yeah. Following and sleeping. Huh? See, we need to compare previous element, isn't it? I already put here clearly UA, like union array K minus 1 is the previous element. Is that previous element equal to the same element that you are looking? Right? I hope this will solve the problem. It's still running. So look at it, how many loops we did. It's still it is order of n plus m, because even though we have three while loops, why it is order of n plus m? Because in the first loop, you know, you completed only the you complete only the smallest array, and in the next while loop only one of these loop will execute. It won't execute both, right? Either if the elements left in the first array, it will execute this one. If the elements left in the second array, it will execute the second while loop. It won't execute both the loops, isn't it? Yay, finally we got the result.
Yeah.
See,
Nice.
this is what we want, like on the fly understanding, and trying to explain and trying to fix the problem. That's it.
Yeah.
Okay. So now let me fix this three lines or these two while loops in my actual code. This is my local code, and here is the code that I am going to give it to you. It's this exact same code. I think we found very good. Actually, we found a bug here. Let me fix that. There you go. Why it's beautify. If I say beautify, come on. Oh my gosh. Beautified like this. My God. It's so crappy. Now I like this. So now what I do is I will just tap, tap, tap. Okay, we are in a good shape, right? So let me save it, and I'm going to share it immediately, because it will take some time for me just to create the final message, but I can share immediately here in the chat. Okay, are we good for today? You like it, or any feedback is welcome?
Yeah, I think today it was great discussion. Yeah, discussing a lot of things. Yeah.
Yeah.
Yes.
Yep. Yep.
Just learn few new things.
Very good, very good. Good to know that. I'm happy if I can able to help a little bit for you guys. Okay, I'm spending all time because only thing is to help the people to understand these things and motivate how to perform in interviews. Okay, interviews is not about completion of the algorithm. Don't think that, oh my God, how can I write these many lines? Oh my God, how can I, execute? It's all only the matter is just the the way you are thinking and the way you are expressing your thoughts. Okay, how you going to approach, just think that interviewer is just your colleague. Just think that is another, just if you are Modit, if you are going to interview, the interviewer is Tarun. Don't think that interviewer is Suresh or somebody, or some manager or some manager. Don't think that. Just think that he is just your colleague, someone who is just preparing like you. Tarun, if you are going interview, just think that the interviewer is Modit. That's it. That will eliminate half of the pressure, isn't it?
Right, right.
Just to think that. Even if you want a full confidence, if you want to get full 100% confidence, think that he is a student. Just think that. Modi, you are just thinking that the interviewer is just another guy who just finished maybe intermediate or just degree. You who don't have basic, who have very basic knowledge. You think that you are superior. That will give you 100% confidence, because you like, if you know, right, if you know something, like just example, on the next day, maybe tomorrow, you want to explain this algorithm to a student or some your relative who just learned about loops. He just know about loops, he know about if conditions. How you explain this algorithm to him? Now you understood every part of this algorithm, right? Now just think about how you
Right.
explain this to some kind of person like that. When you're going interview, think that that guy is something like that. Just you are explaining to that person, you have full knowledge, you got some idea, and you need to put your idea in such a way that they will be able to understand what you are saying, understand your thought process. You need to you need to take him or her along with you, along with your thought process. That's the only thing. So that's what I'm trying to do here, right?
Right.
I know this algorithm. Yesterday, I looked at this algorithm. I completely understood the delete line by line. Now, while explaining to you, did I open the algorithm? No, right? I just opened one or two few seconds. I just opened about the variable names, because I know everything is in my mind, but I want to make sure I want to use the same variables so that you can easily correlate between the whiteboard and the algorithm. So
Actually, you made us to write code how we think.
exactly. That's what it is. Always like,
Yeah.
we need to convert our mind, how our mind process, because we are creating artificial mind, right? What is program? Program is just artificial mind. We are our mind is doing something that we are coding. That's why it is called coding. We are coding so that it will process that code. It will think just like our brain thinks. Our brain has limitations. Our brain can look at these 10 numbers, 15 numbers, and we can easily say the answer. But if I give you the 1,000 numbers here, our brain will take forever. It will take maybe you can still do it. It will take another 4 hours or 5 hours. If I give you 1,000 numbers in A and 500 numbers in B, our mind can do it, but it takes more time. You need to take a pen and paper. You need to take each number and process it, right? That thing, that part we are automating. What all computers are doing, automating the manual process. That's it. So what the manual process means,
Right.
as a person, you are doing with pen and paper, you're automating that. So you always need to think how your mind is thinking. It's just thinking on yourself. I'm able to put the answer here, but how I came with that answer, how my mind looked at the numbers. Always think about that. That will give you the at least half of the algorithm. It won't give you full thing, but at least oh, my mind is thinking this way. Let me try to code that thought process. That's it. Okay. And, and the second process, second thing I said is, take the interviewer or take the candidate along with you. Don't reveal everything at once. Did I reveal all the algorithm at the first attempt? No, right? Did I reveal everything at,
No.
okay, take this while loop, take that while loop, do this, do that, do that? Did I reveal that? I try to explain what is the complexity, why we said it is sorted. I spent more than 10 minutes on this, right? The main process here. What are the different solutions available and why the input is sorted? So these discussions really matter. These discussions will engage the audience into the actual problem here. What is the problem we are solving, and what are the different solutions? What is the pros and cons of each solution? Okay. That is important. Just taking the interview
Yes,
out.
Suresh. Yeah.
Yeah, that's the only thing. Cool, guys. I think we had a good discussion. Uh, I hope it's
Yes.
helpful. But
Yeah,
only thing, just
definitely. Yeah.
you guys have another 6 days. In these 6 days, take at least half an hour and look at this problem. That's very important. Unless you refer it, it won't store in your mind. First thing is whatever we discussed it here, we are storing. I'm recording it. Either watch the recording once or look at the algorithm and and just by looking at the algorithm you will get all the discussions we had. But if you are looking algorithm after 2 weeks or after 3 weeks, you may lose that context, right? So my
Yes.
only request
Right.
is just to once, if you really have 1 hour or 2 hours, just try to code this. Take a white paper and pen, and you understood everything in your mind. You know how many loops you want. You know how many variables you need to take. Just close the laptop and try to write the algorithm and see how many bugs or how many if conditions you will miss. Just validating yourself. You know everything, but while writing is a practice. Writing without pen and paper, there is no point of preparing for this coding interviews. Never ever prepare or write code in a don't repeat it, or practice. Don't practice in the IDEs or the laptops. Always practice with pen and paper. Okay, that's very important. So that's my request is just look at the algorithm at least once. If you still have time, practice on pen and paper. If you still have questions, or if you really have struggled, or understanding anything, look at the video. I'm sending the video recording as well, right? It will be helpful, so that you will not forget our discussions. You will not forget, hey, where we have and what we discussed, and you will be able to catch up. Okay,
Yes. Definitely, sir.
cool
Yeah,
then.
Suresh.
Awesome. I think it's almost like 11 o'clock for you guys, and have a nice rest of the night and have a nice week. So we'll talk next week. Okay. And by the way, so it's not just
Sure.
arrays. As I said, we have different, after arrays, in the next week, we are going to discuss about the two-dimensional arrays, couple of problems, and then strings. There are few problems on strings. String manipulation is also very important and we have stacks and queues, linked list, very important concepts. Linked lists, we have trees, graphs. I'm going to explain. So bring more people. This is very great, sessions and a lot of good knowledge. So I like to share to more people, and getting more people is really, it makes me also like enthusiasm, right? Oh, so this, like, let's explore more and spend more time. I will try my best to give in a better way. Okay.
Yeah, I will share to my below friends.
Yes,
Yeah, yeah.
Suresh. Yeah.
Get more friends. That will help you as well. Like, you will find another good partner in your location. The problem is, Tarun, you are in Hyderabad, he is in Delhi. So once you take off this call, you may not be able to connect again. Even if you connect, you will connect this way only. Like, again, another meeting, Zoom or this thing. But a friend, in a real friend, like
Mhm.
kind of in-person contact is really important when you're preparing. When I prepare for interviews, I spend time so many hours, nights and weekends with my other friends who are also preparing with whiteboarding. We went to the Microsoft campus. We went to the our meeting rooms in the libraries with the whiteboard. We spend a lot of time. That really helps. That discussions, that conversations, that thought process is really helped a lot. It boosts your energy, enthusiasm, and also it will give moral support, and it will help the discussions. Basically, it will help you how you going to present your ideas in the real interview, right? That is the good part.
Yes.
So very important.
Right, Suresh.
Always have a friend, and do it. Don't go with alone. This is very rough road. I would say it's not easy to go alone in this road. So that's what I would suggest. Don't go alone. No. Yeah.
Yeah.
Awesome, guys. See you next week then. Okay.
Uh,
Good night.
all right. Yeah. Good
Awesome.
Thanks.
night. Bye. Thank
Thank you.
you.
Bye.
Bye.
No.